I'm Josephine, Assistant Professor of Physics, Nalasimharadi Engineering College. Now I'm going to explain about energy band diagram of PN junction diode. So this is the energy band diagram for PN diode. So if you join a p-type semiconductor with n-type semiconductor, we know that a PN junction diode is formed. So here this is the energy level diagram for p-type semiconductor. This is for n-type semiconductor. When you join these two, they are going to undergo a relative shift. Now, to equalize the Fermi level of P region and N region, the Fermi levels will undergo a shift. So, this is nothing but equalization of water levels in two containers. Suppose if you take one container which is having high water level, and if you take another container with a low water level, now to equalize the water levels of both container, when you join these two containers together, then the water from higher level will go to lower level, and both the containers water level will get equalized when you join those two containers. The same thing here also for the energy band diagram of PN junction diode. So first let us consider a PN junction which has a p-type and n-type material in close physical contact at the junction. So first let us consider a PN junction which has p-type and n-type which are closely contact. Now the energy band diagram of these two regions undergo a relative shift to equalize the Fermi level. The Fermi level should be constant throughout the specimen at equilibrium. So the distribution of electrons and holes in allowed energy states is dependent on the position of the Fermi level. If this is not so, the electrons on one side of the junction would have an average energy higher than those on the other side. This causes the transfer of electrons and the energy until the Fermi levels on two sides get equalized. As we know that in p-type semiconductors, holes are the majority charge carriers, and in n-type, electrons are the majority charge carriers. So to equalize the charge carriers, they must undergo a relative shift. So however, such a shift does not disturb the relative position of the conduction band, valence band, and the Fermi level. So equalization of Fermi level in P and N materials is similar to equalization of water levels in two containers which are being joined together, as I discussed in the beginning. The energy band diagram for PN junction diode already we have seen in the first slide, where the Fermi level EF is close to the conduction band edge ECN in the n-type material, while it is close to the valence band edge E suffix Vp in the p-type material. It is clear that the conduction band edge in p-type material is higher than the conduction band edge in n-type material. Similarly, the valence band edge in p-type material is higher than the valence band edge in n-type material. Now, to equalize these Fermi levels, they must undergo a relative shift. So here E1 and E2 indicates the shift in the Fermi level from the intrinsic conditions in P and N materials respectively. Then the total shift in the energy levels is given by E naught. E naught is nothing but the sum of E1 and E2. That means E1 plus E2. So which is also equal to ECP minus ECN, or EVP minus EVN, which is also equal to E into V naught. So this energy is the potential energy of the electrons at PN junction, and which is equal to E V naught, where V naught is the contact potential or the potential difference or the barrier potential. So to equalize the Fermi levels in both p-type and n-type semiconductors, they must undergo a relative shift to equalize the Fermi level. That shift is indicated by E1 and E2. So the total shift is represented by E0, which is the sum of both E1 and E2. So this is about the energy diagram of PN junction diode. Thank you.